This is a example of a site which we'll look at for the energy consumption and explain how the average power is different. The energy consumption is useful for many things, one of which is working it to use a battery and how big that battery should be. So let's go straight into circuits. And I'm just going to look at all of them here for a minute. And to make our life simple, let's just look at one. So you can see I've selected a single day. So if I go back over the last, say, 30 days, I can choose which day I'm going to look at. As it turns out for this site, they're all about the same. So I'm going to pick one, let's just say this one, which is the day of the 1st of November. So I'm going to select all that. And that's going to be the day I want to find out how much energy the lights used, which will be the same for all the different days. So here it is. The lights turn on at 5 and they turn off at 9. So that's 4 hours. And on average, the lights are running at a power of 15 kilowatts. So we already know that we can work out the energy because 15 kilowatts times 4 hours is 60. So we expect the total energy to be about 60 kilowatt hours, but we want to get an accurate figure on that. So let's have a look here. This tells us the energy used within the time period. So depending on what this number is, that's going to affect, because if you're running for 2 hours, that's going to use twice as much energy as if you're running for 1 hour. So let's zoom in a little bit more and we'll probably get an interval of about 1 hour. Okay, so now they kind of coincide. So for every hour, for this hour between at 5 o'clock, it was running at about 15, 14 kilowatts of power. It ran for an hour, so it used 15 kilowatt hours. To make that even easier, there's this little set of tables down here which says, tell me of the period that I've selected, what was the average power and what was the total energy used. So for this one, the average power is actually going to be somewhere down here because it was off, or 0, 0, 0. Then it was on at 15. So I reckon the average power will be maybe 3,000 watts for lights F1, F2. Let's have a look. Lights F1, F2, no, even lower. So 1,000. So the average is actually way down here because it's off most of the time. And then the energy, which is all of these combined. So how much energy did F1, F2 use? We initially worked that out to be about 15 kilowatts times 4 hours, or 60 kilowatt hours. And more exactly, it's 57 kilowatt hours. So short version is that if you select the circuit and the period with the time selector, this number here is the total energy used. So if you had a battery that was 57 kilowatt hours, it would supply enough energy to run those lights. And coincidentally, it costs $17. That's really it. So just to recap, the power is how much it's using for every single instant. You can see all these little bits, and the energy is added up over the time period, and you can get accurate numbers from these two columns, power and energy.